This is the modern periodic table. 118 elements are arranged in this table in a very systematic manner. There are some properties which are related to these elements which define the way in which these elements react. Since the elements are arranged in a very well organized manner, even these properties follow some particular trends. Let's see how. One important property that is related to the elements is their electron affinity. It is abbreviated as EA. We know to remove an electron from an atom, we have to give energy to the atom. So when an electron is added to the atom, energy is released. So to remove an electron, we give energy to atom, and when an electron is added to atom, energy is released. So the amount of energy released while converting a neutral gaseous atom. We talk of gaseous atom because by saying gaseous atom, we mean an isolated atom. In liquid or in solid state, the atoms are associated with other atoms. So to talk of isolated atoms, we say that we talk of the neutral gaseous atom. So the amount of energy which is released when we convert a neutral gaseous atom. So now we are adding an electron, so it converts it into a negatively charged ion. Electron affinity. From affinity, we mean attraction. So from the term electron affinity itself, we mean the attraction of electrons towards the atoms. That is, electrons are being added to the atoms. So greater is the attraction of electron to the atom, greater is the energy released, and vice versa. So we have an atom and we add an electron to the atom. This is the electron affinity, and in doing so, energy is released, and this energy is known as electron affinity. Since an electron is added to the atom, it converts it to a negatively charged ion. What happens in a periodic table? How does this electron affinity vary? We know when we move from left to right in a period, the atomic size decreases. When we move from top to bottom in a group, the atomic size increases. So let's see what happens pictorially. As we move from left to right in a period, the atomic size decreases. As a result, the outermost shell comes closer to the nucleus. So the nuclear effect on the outermost shell increases. The attraction of the electrons towards the nucleus increases. Hence, there is greater affinity of electrons towards the nucleus. So the electron affinity increases. That is, greater the affinity of electrons towards the nucleus, greater is the energy released when electron is added to the atom. So let's revisit what happens when we move from left to right in a period. The atomic number increases because we know the periodic table is arranged in increasing order of atomic number. As the atomic number increases, the nuclear charge increases. This nuclear charge leads to the greater pull of the outermost shell towards the nucleus. As a result, atomic size decreases. This leads to effective attraction on the valence shell being increased. Therefore, the greater energy is released when an electron is added to the atom. Since the affinity towards the nucleus increases, greater energy is released. Therefore, the electron affinity increases when we move from left to right in a period. So we have three elements: boron, carbon, and nitrogen. Which of the three has the greatest electron affinity? Let's locate them in the periodic table. So we have boron, we have carbon, and nitrogen. We just studied that when we move from left to right in a period, the electron affinity increases because the size decreases, the nuclear pull on the electrons increases, so the affinity of electrons towards the nucleus increases. Hence, on moving from left to right in a period, the electron affinity increases. So out of boron, carbon, and nitrogen, nitrogen is the element with the greatest electron affinity. Let's see what happens when we move from top to bottom in a group. So we know that when we move from top to bottom, the atomic size increases. This is because of the increase in the number of shells, which overweighs the increased nuclear charge. As the atomic size increases, the distance between the outermost electron and the nucleus increases. This leads to lesser affinity of electrons towards the nucleus. As now the affinity of electrons towards nucleus decreases, lesser energy is released when an electron is added, and therefore the electron affinity on moving from top to bottom in a group decreases. So let's revisit again. On moving from top to bottom in a group, the nuclear charge increases. Also, the number of shells increase, which overweigh the increased nuclear charge. We know the effect of nuclear charge is that it tends to pull the outermost shell closer to itself, but the increase in the number of shells, they increase the distance between the nucleus and the outermost shell. They overweigh the increased nuclear charge, so in effect, the atomic size increases. This leads to effective force of attraction on valence shell being decreased, hence lesser energy is released when an electron is added. As the distance between the outermost shell and nucleus increases, there is lesser affinity of electrons towards the nucleus. Therefore, the electron affinity on moving from top to bottom in a group decreases. So in a periodic table, when we move from left to right across a period, the electron affinity increases. As the atomic size decreases, the affinity of the outermost electrons towards the nucleus increase. As the affinity increases, greater energy is released when an electron is added, so the electron affinity increases. On moving from top to bottom in a group, the atomic size increases. So the outermost shell is away from the nucleus. There is lesser affinity of electrons towards the nucleus, so lesser energy is released when an electron is added to the atom. So the electron affinity decreases when we move from top to bottom in a group.